Section 3.4 Concavity and the second derivative test. In section 3.4, we are going to learn about relationship between f and f prime and f double prime. F double prime also gives you lots of information about your graph of f. It gives you the shape of graph. It gives you the inflection points. It also can tell you about relative extrema. So let's start. Concavity. Test. F double prime of x is greater than 0 implies f is concave up. So what does it mean to be concave up? Your graph shape will be a cup shape of any side of rounded cup at the bottom. So if you look at the first graph here, I have graph that is decreasing, but it's the bottom of a rounded bowl shape. The sign of f prime is negative because graph is decreasing. However, according to the test we just saw above, because graph is cup shape, f double prime sign of this function will be positive for concave up. Let's use CU for concave up. Now, look at the second graph here. I have graph that is increasing, which applies your f prime is positive. However, this is also bottom of a cup shape, which is the concave up. Therefore, f double prime will be positive. So note that signs of f prime has nothing to do with the signs of f double prime. F prime is negative, but then f double prime is positive on the first case. And f prime is positive, but f double prime still positive on the second case. So basically, f double prime sign has nothing to do with f prime sign. Test. F double prime of x is negative, then f is concave down. This reminds me of a shape of umbrella. And for the concave up, I think about cup. This cup has UP in it already. So this is how I memorized when I was a student. And then the other one is concave down, down for negative, and it is umbrella shape. So as you see, the third graph, because graph is decreasing, we know f prime here is negative for decreasing graph of f. However, since it's umbrella shape, it's concave down. So f double prime sign will be negative. Fourth graph is increasing as x gets larger, y is getting larger too. So f prime is positive here for increasing graph of f. However, f double prime is negative since it is concave down. Given the graph of f of x, sketch the graph of f prime of x and f double prime of x. So I have f of x almost looks like a third degree polynomial. So that kind of helps me to sketch f prime of x, knowing that this is almost similar to shape of third degree polynomial. Then I know my f prime graph should be kind of look like parabola, second degree polynomial. So here at A, we have a relative maximum, and at C, we have a relative minimum. And since this is not sharp turn, I know f prime of A is 0, and f prime of C is 0 as well. And if you look at the graph, from negative infinity to A, your graph is increasing. So f prime should be positive from negative infinity to A. Now, since my f is decreasing from A to C, my f prime should be negative between A to C. And then after C, my graph is again increasing, which means my f prime is going to be positive. And that gives me very good information about my parabola shape. And then, not only that, you can see at about point B, I have the steepest negative slope, which means out of all negative slope, negative number f prime, I will have lowest point at B. So now I can shape the graph. It's increasing, but you can see it's a steep there, and it gets a smaller and smaller positive number. So you get greater number and gets closer to 0. So let's say this is the lowest number, since I need to get back up to hit the 0 and go over the positive. So my graph of f prime of x look like that. Now for f double prime graph, I'm gonna use what we just learned today. From negative infinity to point B, my graph is umbrella shape, which is concave down, which means f double prime is negative there. And from B to infinity, my concave is up, which means f double prime is positive. And knowing that my f prime is the shape of a parabola, my f double prime should be a first degree polynomial, which is a straight line. And knowing from negative infinity to b, it is negative, and b to c, it is positive, I will have a line, I will have a shape of a line like that. Make a sine line graph of f double prime of x to determine the intervals where f of x equal 4 over quantity x squared plus 3 is concave up and concave down. So first, to do this, we need to find f prime of x to get the f double prime. So f prime of x is equal to, how would you like to do this? I prefer to rewrite this as a 4 times x squared plus 3 to the negative 1 power, so that it is just the general power rule with a chain rule combined instead of using quotient rule. But if you want, you can use the quotient rule. So then f prime of x equals negative 4 x squared plus 3 to the lose 1 power, I get negative second power times chain rule. Now I multiply by derivative of inner function, which is 2x. Then numerator will be anything that do not have any negative exponent. So I will multiply negative 4 and 2x. I get negative 8x. Send the negative exponent to denominator, and you will have x squared plus 3 to the second power. So we have the first derivative, but we need the second derivative to determine the interval of f is concave up or concave down. So let's find the f double prime now. F double prime of x. This time, since I have a function over function, I would like to use quotient rule. So let's go ahead and do low x squared plus 3 quantity square times d high is negative 8 minus high is negative 8x, d low, derivative of the bottom function is 2 times x squared plus 3 to the fourth power times derivative of inner function 2x over square below. So now I have quantity x squared plus 3 to the power 4, since I'm squaring it. Let's look at the numerator. I don't want to multiply all this out. Rather, I want to factor out right now the way it is. So I know this is actually negative, so this is a positive. Since this whole product is negative, it's gonna turn into a negative, which is a positive. And I can see the first factor has a negative number in it, so we can take the negative 8 out. And also, I have x squared plus 3 to the second power and x squared plus 3 to the first power. So common factor is x squared plus 3 to the first power. Negative 8 is out. X squared plus 3 to the fourth power is out. So from the first factor, I get still 1 factors of x squared plus 3. And because it is power 1, I will not use parentheses anymore. And I took the negative 8 out, so this should be negative in between now, so that negative times negative gives you positive back. And 8 is out, so now look at the rest of factors that did not come out, which is x times 2 times 2x. This quantity is out, so you have 4x squared over x squared plus 3 to the power 4. Then you can see from numerator and denominator, we both have x squared plus 3 factors, so we can cancel one of them each. So this can be canceled, and this can be canceled so that you only have 3 factors of x squared plus 3. So then now you have negative 8 inside become negative 3x squared plus 3 over x squared plus 3 to the third power. I'm gonna pull out negative 3 factor from parentheses on the top. So then when it comes out and multiplied by negative 8, it's gonna become positive 24 x squared minus 1 now, but x squared minus 1 factor as x plus 1, x minus 1 over x squared plus 3 to the third power. So I found f double prime now. Since f double prime is positive, it is concave up, and f double prime is negative, concave down. It is very helpful to draw a number line and then locate the all critical numbers of f prime. So critical numbers of f prime is any number that make f double prime equal 0 or f double prime does not exist, but f exists. So when is this f double prime ever undefined? Well, x squared is greater than or equal to 0. So when you add 3 with it, it can never be 0. It's always a positive number. And positive number cube is a positive number. So this will never happen. And then when is this f double prime ever 0? It will be 0 if numerator is 0. Numerator is 0 if x equal plus or minus 1. So those are the two numbers that f double prime will be ever 0. So this is signs for f double prime. And here is negative 1, and here is a positive 1. And I want to find out intervals where f double prime is positive or negative. So again, yes, you would need test points. And you will pick a test point on each interval, but you are testing the f double prime. So you're going to plug this test point into the f double prime. And again, I will use factored f double prime so that I can just look at the sign, since all I needed to know is whether it is positive or negative. So pick test numbers in each intervals. I'm going to pick negative 2, 0, and 3. Of course, you can choose some other number if you want. Make sure those number belongs in that interval. So now I'm going to plug these test points where now? You have to plug each of these test points to every x you see in the f double prime and determine the sign of it. So 24 is just set to be a positive number, so that doesn't affect anything. And I plug it in the second parenthesis. Negative 2 plus 1 is negative. Negative 2 minus 1 is still negative over negative 2 squared is a positive, plus 3 is a positive, to the third power is positive. So since in the quotient I have a 2 negative, so it's going to be equal to positive. So f double prime sign for negative infinity to negative 1 is positive, which means graph of f will be concave up on this interval. Get it? Now let's test f double prime of 0. So now let's plug 0 for all x you see in f double prime. Then 24 is a positive, and positive number doesn't affect. 0 plus 1 is positive, 0 minus 1 is negative, 0 squared is 0, plus 3 cubed is positive. And since you got one negative in the quotient and the product, this result is negative, which means your graph of f will be concave down in the interval negative 1 to 1. And then test the number 3, plug 3 to every x you see in the f double prime equation. So then 24 times 3 plus 1 is positive, 3 minus 1 is positive, 3 squared plus 3 cubed is positive. So this is positive, which means your graph of f will be concave up again from 1 to infinity. So now you can answer the question. Your graph of f is concave up on negative infinity to negative 1 union 1 to infinity, and f is concave down on the interval in the middle, so on negative 1 to 1.